Hello, good afternoon. Welcome to part 3 of this series, DataQuest guided project for a profitable app profile using data from App Store and from iOS. This is the part 3 of this series. If you have not seen part 1 and 2, please check the comment section, the description section below. I will try to put them there. And then so you can at least be in sync with what we have discussed before. So let's get a business. So the last time we have discussed, about removing duplicate and stuff like that, and this is quite interesting. I'll quickly take you through what we have done the last time. In part 2, we of course find a duplicate, we removed it, and we find a duplicate, we remove it, and we actually delete it, and not just randomly, but based on some specific criteria like the number of reviews, the one with the highest number of review. And we wrote all this code, and then we are good. And I hope you get it clear in the part 2. In case it's not clear enough, please leave some comment in the comment section below, and I will try as much as possible to get to your question and I'll try to explain to you better. And don't forget, remember to subscribe to this channel so that you can get more wonderful content like this. And remember to also turn on your notifications so that you can get the latest, the artist, and the most reasonable and cool videos from this channel. So let's get a business. Good. So this is the outline we've been following. We've done this in part 1 and some part of this also in part 1. So we have done this in part 2. We have explored the data. We have delete duplicates. Now we'll continue with removing non-English apps and removing paid apps, and let's see how much we can do with now actually cleaning the data. And then let's see, we clean and we explore, and this is doing the real analysis, but we will see, and then we'll see, and we are going to be able to understand more of the process. I will try to explain everything as much as possible, step by steps. So let's get a business. So after we have removed duplicates, I think the most reasonable thing is to, some of our criteria is we also don't just want non-English app, we want only English applications. And then this is reasonable because different languages, and if you look at this app distribution, there's a lot more people that are English speaker or English application with English as their as the language, so that we can engage with more people. You remember the aim of this project at the beginning is so that we can get more users and people that engage more with this app, so that we can sell in app ads. The application itself will be free, so just let's get a business. So in order to make things quite easy, I make some notes here and there explaining what we are doing. And don't worry, I will put up this in the description at one point. So let's just keep going. So basically, this is what we're supposed to basically do. As I've said, is only for non-English speakers, because we can also validate this since it's a kind of public information. And then let's assume that we don't even have public data, because I showed you we have it on Kaggle and also on for the Android and also for the iOS. And of course, just it's not only English that is spoken in the whole world. So even though you're not very sure and you don't know the index, you don't know which row, you can of course build some function like we did, loop around it, check and see if it is English language name or something. But yeah, we can quickly do something just to establish that we are quite sure that we have at least some non-English apps. For example, if we check for the Android application, so we can print some index and just see what is there. We call it Android data, right? Android data. Android data clean. I think that's what we have now. And then we have 4412. Of course, that is the row. Then we pick the first column in this row, which is of course the name. As you can see, that is some Japanese or some Chinese, I'm not so sure. And then of course there are also like older examples that I will just copy and show you here, because you shouldn't waste a lot of time on this typing. So if you just see, I think I'll quickly change this one to iOS data, and then iOS data. Sorry, because I've used different name from different solution that I made before, but it doesn't matter. At least it's also a good avenue for us to at least practice naming and stuff like that. Yes, so let's see. Good. As you can see, we have some Arabic there, or some, yeah, I think some Arabic. Just the main thing is like these are not English apps, as we can see. So you can put some space there if you want to put something there, just to, yeah. This is quite good. And then, yeah, we are good. So after establishing all these, we are pretty much sure that we are actually correct with our guess. So what is the next logical thing to do? There is something we call ASCII, or ASCII, or I don't know what they call it naturally. I think it's something like this. So like we have an American standard code and stuff like that. The main point is that each alphabet, each numbers, they have some like encoded, like some SHA code, some character codes, with which computer can understand that, okay, if I write letter A, for example, if I write letter A, that means something like 65 or something, if it is small letter, if it is this. So this is what we want to use. And I would, of course, as usual, give the explanation here so that you can at least see what we are talking about. You can always check this explanation at your free time, but it's there for you to see. So each letter, we have the 0 range 0 to 127, especially for English alphabets and numbers. We have this range from 0 to 127. You can at least just say ASCII code for English, for example, English letters. And then let me quickly open this and we can see it together. I don't know why it's not secure, but yeah, let's see. Yeah, there we have it. You can see small letter A is 97 and capital letter A is 65, just like I wrote. And of course, they also have their binary, but the ASCII code itself is what we're interested in. So, and it actually range from 0 to 127. And so we have 122 there with, of course, special characters and stuff like that there. So yeah, that is that about that. I don't know if I can also put this in the description so that you can also have it. But if you just search, you will always have that information there. So now let's get back to business and let's just continue. So we are capitalizing on this ASCII thing, 0 to 127. That means if we loop through each character of this word, for example, and of this name, and we see this is not between 0 and 127, then that means that this is not, at least, is not supposed, presumably, to be English word. And of course, we'll have to do some catch up somewhere later, because what if it's not some, it is an emoji and stuff like that. But we are going to be fixing that. So let's first quickly write this, at least this function, to identify at least, let me say, like this name, if it is actually like if it is actually some sort of like English alphabet or not. But there are different approaches to this, and then depends. Let's see. We can first check and see if, yeah. So let's write this function. We define this and say, is it English? Is it the English name or something? You can write it anyhow you want it. So string. And then, but even before that, I will quickly show you something which we call odd. We call it odd. Let's say odd A. And let's just run this and see. Yeah, This is what Python gives us. If you run this function, you can easily get the shell code of each alphabet. So let's build a function around this, and you can actually see what I'm talking about better. So it's English, so we're just going to pass the string itself, the entire string, and of course we can put a counter here. I'll put like a counter or something, or total. I will tell you why we need this later, but just follow along with me. And I say for each character in string, for example, if the odd, that means that I want to get the ASCII code of that character, if it is greater or equal to 127, that means, let's see what that means. That means that we can increase the count, right? Yeah, we want to see if the number of, we want to see the number of non-English characters in this string. Of course, you can check each alphabet and check if each one of them is actually English word, English character or not, English letter or not. But I think this is a robust solution because you can just count the number of non-English characters there. It's like you're working in opposite now, and just see what happens. Then, of course, if this should contain more than 2, more than 3, yes, I think it's 3 that we want to check at the end of the day. Then that means this possibly should not be a non-English like a name. So we want to count. Of course, we want to increase the count by 1. Then if count is not greater than 3, then we want to return false. Right? It's capital F, false. Otherwise, if this is not true, we just want to return true. Hey, I think this is, of course, sorry, that should be inside, not, that should be inside the, that should be outside the for loop, but inside the function, the entire function, as you can see. So I'll quickly explain this. At the beginning, we're collecting a string name, for example, Instagram, this and this, or even all these non-English characters. Now we are setting a counter variable, and we loop through each of the string, because you remember, in Python, string is just literally considered like a list, so you can actually just loop through it like a normal list. We are checking if, for example, you get the character here and is greater or equal than 127, you want to increase the count by 1, right? Otherwise, and if this happens and we keep increasing, and second time we go and we also increase it again, then if this count is greater than 3, so that means if we have more than 3 non-English characters, that means that is not actually an English name. We presume, of course, this is not the best solution, but of course it still works. And you can, of course, play around with these and give more strict like conditions and stuff like that. Maybe check character by character if you find anything that is not equal, but that would be like too strict. Then of course, what if you have emoji and stuff or special characters, so that are not even non-English special characters? Otherwise, we want to return first, which means that this is not even like passed at all. We don't have all this. We just return true. That means it's an English name. So we can quickly test it. Just to be sure, I will just put this, for example, to test. So we missed our colon here, some syntax error there. Good. So Instagram, of course, is completely English word, but of course this is not, because we have, of course, we have PPS, but we have a lot. This is not English. This is not English. This is not English. So if you already have this is not English, if you have 3 of those that are not English characters, what do? We return first. And of course, this is still English because we only have 1. Because if we check, for example, I copy that and I check the odd number, the odd of that, what's it called, of this TM of 18, or let me try to copy it, choose C, and I just check. Look, it gives us 8482. It's not even within 124. So that's why, because it's only one of these instances, it's not 2, it's not 3. So let me just put, for example, 1, 2, 3. Now that is like 4. Let's see what happened. That will become false. So that means it's no longer English. We are not considering it again as English. So of course, nobody will put like trademark 4 times in the name. It's okay to just have only one there. And this is still true again. And in the case of emoji, I'll copy, for example, this emoji, and you can see what happens. So you can see now we have like this really large number. So this way we have just like a workaround, and this is still work, and it's okay. So now that we have a function that we can use to like grab and check a string name if it is English or not, and I think we can use this in our entire data set. And how do we do that? I will quickly, of course, put some instructions here, what we're supposed to do, or some explanation of what we have done so far, so that you can see this function above can be used below to isolate the English apps from the Android data. So it's no more English data, it's from the Android data. Yep, and iOS data. Yeah, from the previous step. So let's just go for it. And just as usual, we do the same every time. We loop through the data set, we check the name of the app. So let's just start building this function and see what is there. So we said English apps, for example, English apps. Of course, we collect the data set because we want to write a function so that we can use it for both Android, iOS, or any kind of data set. So let's build this data, let's build this function. And for example, iOS, I just want to write one and just use it once and for all. That's why I'm writing this. So you might find different solution from different places, but I think this is okay and it still works, so why not? Let's just use it. Because I don't want to be writing the for loop 2 or 3 times and whatever. It doesn't matter, you still get the same answer, but it's okay. Because you should also at least practice how to write your function and everything. So yeah, let's go. So I say, for example, iOS, that means iOS data, or is it iOS or not? Then if it is that, I just set English apps data. I set that to be empty. Then I say for app in the data set, of course, this is now what we are going to look. App name underscore, of course, this is for Android. That is equals to the first one as usual. Then app name iOS, because it's on different columns, so I need to pull it out differently. So if not iOS, so if it is not, that means if it is Android, of course. If is English, if it's Inc. Now we are using the function now, app name. The function that we built here, you remember is Inc. Yeah, if it's Inc, comma. That means if it is Android, because of course it's not iOS, that means it's Android. Yeah, we want to append English apps data dot append the app. So if it is iOS now, what do we want to do? If is Inc and app name iOS, I want to put English apps data dot append the app. They want to return, don't worry, I will explain this nicely. So we want to return, this should be, yeah, I think it's, yeah, it's outside the loop. I want to return English apps data. Yeah, so let me quickly explain this function. It's quite robust. So yeah, let's go for it. So now we are creating this function that we can use to check any kind of data set, and of course we don't care if it is iOS or if it is Android. Alright. So in essence, we are checking if it is English apps data. We are creating an empty list. And we loop through this data set, and of course we pull out the name. If it is Android, it has to be on colon 0. If it is iOS, it has to be on colon 1. Now, if it is not iOS, that means if it is not, that means it should be Android, of course, at least in this case. If is English app name Android, right? If we check and when we pass this is true, that means that we are pulling out this. Then of course now we want to append the app for not iOS, that means Android. Now if iOS, I think there was some mistake here. Yes, if iOS, then if is English, now is iOS, we are going to use iOS data here. Then of course we just append this information only for the iOS. Then of course we return this empty array that must have been populated now by appending the application names. So now let's try it and see what happens. You can easily say Android data clean, of course English. It's quite a long name, but I don't know. You can just like give it any name you want. So of course it's a function. Now we can say the data set is what? Data set is Android data clean, right? Now in this case, since we can easily pass this because we are checking only for iOS, and that means, we are checking only for Android, and that means iOS is not true. So if we run this now, let's see what happens. Okay, let me just log it. So that's why we didn't see anything. So now we have all these, like, you cannot find any kind of non-English character. Everything here is expected to be English apps. So let's do the same also for the iOS. So I'll say iOS data English, for example, that is equals to English apps, and that is data set equals to iOS data. Yes, iOS data. I think that is what we used the last time. Yeah, I think unique app, I think. Yes, iOS data, so we are correct. So, but then we have to pass the second parameter, which is iOS in this case is true. So what does this mean? It means that this is true. Normally, this is true. Because we are using this, it will just jump here. And if not true, that means this one will be false. It will not even it will not run this code. So this is why this function is quite robust, and you can use it for any case. So now if we try to console log this one, for example, you can just say iOS data English, and now you have it there. So that is that for iOS English app. And if you really want to just explore and just see things by yourself, you can of course easily just call our explore function again, explore data, and it's actually a function, and we call it, we pass this to it, Android data clean English, then we pass 0, let's say 03, and of course we want the rows and the colon information also. So let's run this. Now we have 9614 and 13. Let's see if that is correct according to what we're expecting. Yeah, I think this is what we're supposed to get, and we can of course easily do this also for the other one. And let me quickly change this one to iOS data English. Yeah, so this one will just be iOS data English. Yeah. Oh, and also this is the number of rows that we are also expecting here. So now that we have been able to successfully clean this data from non-English application, from our schedule, the next thing we're supposed to do is to remove, of course, paid apps, because we don't want applications that are not free. We only want to get free application. So that is some instruction on what to do and what we are doing. So now let's see the function and let's just build it together. So, and if I quickly come back to DataQuest, for example, we have deleted the wrong data, and in the last video, we removed the duplicates. We also we just build the whole function using the dictionary. Then we remove non-English app. This is what we just finished. So you can of course check out what we are doing and just check it together. And of course, we remove non-English part 2. We've also done that because we build the function first and then we use it the second time. Now let's work on, this is number 8 now. So let's work on removing the non-free app, or just isolating the free apps. So I think it's this one. Yeah. So we can just say this like a free apps or something. Of course, the data set as usual. And then I just do almost the same thing that we did the last time, because of course you can always do it in a different way, but like using the for loop 2 times, I think it's one way, but another way is also to just build one robust application that you can just use it as many times as you want for any data set. So we just, of course, this is also false. Then we are saying free apps data or something that is equals to this, and then for app in data set, now price Android equals float app. Now we want to convert the price, of course. We want to convert this price value. We want to convert it to float, the number, and of course we want to remove this dollar sign, because if we go to this, I'll quickly show you. I think it's from here, colon price. Yes, you can see we have this 0 point something whatever, but we don't want this. Majority of the one we are looking so far is free, but there are some with numbers and with the price, and you can see this is, we want to remove this dollar sign. This is why we are running this strip function. I mean, to just remove this extra dollar sign, because of course we don't want to work with that. So if it is not iOS, yep, what do we want to do? If price is Android now and is equals to 0, I don't know, I think I have to remove this ABS something. There was some syntax, it related to some syntax error. And now we want to just say free appends data to this list that we made at the beginning. We just take it. If it is free, that means the price is equals to 0. Just append it to this. Now let's check if it is iOS. That means we have iOS to be true. And price of iOS now is equals to float, and we just say app 4. This is on the 5th column. So if price iOS is equals to 0, that means it's free. What do we want to do? We just want to append as usual. Dot append application. Now the entire application, not the name, not the price, but the entire application. And of course at the end we just want to return the free app list, apps data list. There you are, there we are. So now let's just quickly use it. I can just quickly copy this also. So we'll just, we can just say Google Play clean or something, or final, I think. I mean, just to make our life easier or something like this. I guess. So we can just say Android data finder also, and that would just be we're using this free apps function. And dataset now is not just the clean but the English. Yes, and of course iOS is false, it's okay. And let's quickly check this. So I can just say Android data finder, for example, and then we can check the length just to be sure that we are doing it right. And then yeah, and that is correct. That is 8864. So we can also do exactly the same for the iOS. So iOS data finder. So that would be iOS data finder. So free apps, iOS data now. iOS data clean English, is that what we call it? iOS data English, yes, iOS data English, there's no clean there. And of course iOS is true. So let's see what this is going to give us. Yeah, so that gives us 3222, and that is correct. We can just print it, just have the 2, just say final length of Android data after cleaning and whatever. You can call it anything that you want, it's okay. As far as you understand your own analysis, I think this is more important than any other thing. And of course, you can also put it in writing for other people that are interested in your work. So that's why I'm putting all these explanations. So this is iOS. I think we made some mistakes here, and that should not be there. It should be like this one. And of course, this should not also be like this one. Yes, as you can see, 8864 and 322. And here we are. Now we are pretty good with the cleaning. We have removed like non-English application. We have removed like, we have removed paid application. We have removed duplicate. So we've done a lot of analysis here so far. I mean, data cleaning, yet to do analysis, sorry. So we've done all this, and I think we are pretty much okay. So I think this is getting really long so far now, but I would really like to continue, but I think I have to put it into another part, because it's better to explain better and make it clearer than just making like 50 hours video. I think we should stop here, and then thank you very much for stopping by, and I hope you enjoy and you've learned something. And if you have some questions or some clarifications, please put your question in the comment section below and I'll try to answer. And don't forget to subscribe, turn on your notification, and see you next time. Happy coding!